we'll be talking about the closed organ pipe and the open organ pipe. Let's first talk about closed organ pipe. Let's say there is a tuning fork here which sends sound waves of frequency nu. The equation of these waves is these waves get reflected from here, and let's say the equation of the reflected wave is superposition of these two waves will take place, and the equation of the resulting wave would be given by this. This is the equation of standing wave. Let's say this length is L. X is taken in this direction. So here we have X equal to 0. Here we have X equal to L. When we talk about reflection, through a rigid boundary, then it is opposite to the reflection when we have open boundary. In case of open boundary, when the wave comes, it finds discontinuity in the medium. You have atmosphere here. Suddenly, after this point, and the pressure here would be atmospheric pressure. That pressure can't be changed. When sound wave travels, pressure changes. But here, pressure cannot change at all. and hence this is pressure note. This is the opposite case. Here pressure would be maximum. That would be pressure antinode. So here we have closed boundary, pressure antinode, and here we have pressure node. So at x equal to 0, we have change in pressure 0. At x equal to L, we have change in pressure maximum. To have this condition at any time, we must have cos delta by 2 equal to 0. Let me choose delta as pi. So P is sine of 90 plus theta cos of 90 plus theta Now coming to this condition, P will be P max at x equal to L if sin KL mod is 1. Or sin KL equal to plus minus 1 or KL equal to odd multiple of pi by 2 K is 2 pi by lambda lambda is 4L by 2N plus 1. Speed of sound is nu lambda. Nu is the frequency of the tuning fork. So nu equal to two n plus 1 V by 4L. The minimum frequency is obtained by putting n equal to 0, denoted by nu naught. It is called fundamental frequency. It will be V by 4L. The next frequency will be obtained by putting n equal to 1. It will be 3V by 4L or 3 nu naught. Next can be obtained by putting n equal to 2. We can go on and on. It can be seen that we are getting odd multiples of nu naught. This is called third harmonic. This is called fifth harmonic, and so on. This is the first frequency which is higher than the fundamental. This is called first overtone. This is the second higher frequency after fundamental. This is called second overtone. So third harmonic or first overtone, fifth harmonic or second overtone, seventh harmonic, the third overtone, and so on. We can also say that L is two n plus 1 lambda by 4. We know that the distance between consecutive nodes is lambda by 2 and the distance between consecutive antinodes is lambda by 2 and the distance between consecutive node and antinode is lambda by 4. So when n is 0, which happens in case of fundamental frequency, L is lambda by 4. That means there is one node here and one antinode here. That's it. In case of n equal to 1, we have L equal to 3 lambda by 4 and we have third harmonic or first overtone. In this case, we have this situation. This is lambda by 4, another lambda by 4, another lambda by 4. So 3 lambda by 4. When n is 2, we have fifth harmonic or second overtone, lambda by 4, 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 5 lambda by 4. And we can go on and on by putting higher values of n. In case of open organ pipe, we have pressure node here, pressure node here. So at x equal to 0, pressure is 0. At x equal to L, pressure is 0 as well. To get pressure 0 at x equal to 0 at all time, cos delta by 2 would be 0. So this still holds good. So this is valid. At x equal to L, pressure should be 0. At all time, that frequency fundamental frequency is obtained by putting n equal to 1. Next higher frequency will be twice nu naught as it will be obtained by putting n equal to 2 and then putting n equal to 3, it will be thrice nu naught and so on. So here we find that it is not just the odd harmonics, but both odd and even harmonics are possible. That's the reason also why the sound that comes from an open organ pipe is superior in quality in comparison to the sound that comes from a closed organ pipe. When n is 1, we have fundamental. Then L is lambda by 2. Lambda by 2 is the distance between consecutive notes. Between two consecutive notes, we have one antinote. So we have n, a, n. For second harmonic or first overtone, we have n equals 2. So L is lambda. N to n lambda by 2, n to n lambda by 2. So total is lambda. When n is 3, when we have third harmonic or second overtone, lambda by 2, lambda by 2, lambda by 2, 3 lambda by 2. And we can go on and on. It is also important to note that since at this point we are having antinote, there is constructive interference between the incident wave and the reflected wave. So the reflected wave is in phase with the incident wave. At this point, since we are having note, there is destructive interference taking place between the incident wave and the reflected wave. So the incident wave and reflected wave are pi radians apart. I've been talking about pressure waves almost all the time in this discussion. That's because pressure waves are more important for us in case of sound waves discussion. However, one can also talk about displacement waves. And then some things may change. For example, here we say constructive interference for pressure waves. But since we can't have displacement here, it's a rigid enclosure, it has to be displacement node. So there must be destructive interference taking place as far as displacement waves are concerned. And likewise, here displacement should be maximum here. It's open space. So we should be having displacement antinode here. And that means we must be having constructive interference here for displacement waves. Pressure antinode is displacement node. Pressure node is displacement antinode.